Welcome to the Automotive Diagnostic Podcast. We're going to explore ways to sharpen our diagnostic skills, find learning resources, and hear from experts in the automotive field. Okay, hello and welcome automotive world to another episode of the Automotive Diagnostic Podcast. My name is Sean Tipping. I will be your host today. Thanks so much for tuning in. Today, I'm going to go through a case study on a 2013 Ford Escape with a 1.6 liter turbo EcoBoost engine. This Ford had a couple different issues that I ended up working through, and both of which occurred after the engine was replaced with a used engine. So I'm not actually sure what happened to the old engine, damaged in some way or another, but the shop, they replaced the engine, and they ended up having a couple different issues with this after the engine replacement, and just some interesting problems to work through. The first thing that they called me for was that after they had replaced the engine, that it overheated on them. And this is going off of the gauge on the dash, on the instrument cluster. This thing would skyrocket. It would peg all the way to the red very quickly after starting the engine. You could start this thing, ice cold. I've been sitting for a long period of time, obviously full of coolant. They checked that stuff. They bled the cooling system. They filled it up. And I think they even replaced a couple of the bypass valves, maybe the thermostat. It didn't really matter, but they had attempted to fix this overheating problem with some parts replacement, and they couldn't. But you fire this thing up, you turn it on, room temperature engine, 70 some, I guess it's a little warmer around here right now, so 80 some degree coolant. The gauge would move up to the halfway mark very quickly after starting. And I will say there are some shut-off bypass valves within the cooling systems of these 1.6 EcoBoost engines, and they do actually get up to operating temperature very quickly when they're operating normally. That's kind of how they're designed. But this was quick even for that. And then shortly after that, and I'm talking within 30 seconds of starting this thing, it would be in the red, sky high overheating. Now again, this is according to what we're seeing on the instrument cluster. There's a warning that comes over the instrument cluster, says overheating protection mode. Obviously there'd be a loss of power if you were to attempt to drive it at this point. And there's also a code being set in there that says overheat protection mode as well in the PCM. Now the shop was able to go in with the scan tool and see that the coolant temperature was not actually at a point where it was overheating. And they could tell that with an infrared temp gun pointing at the engine, and just common sense. I mean, this thing hasn't been running for more than 30 seconds. It's pretty doubtful that it's 240 degrees or whatever the gauge is indicating as far as it's really, really hot. So something's not right here, but they're not sure what it was. And they're also not sure what issues existed prior because the vehicle wasn't running when it came in. But that's the scenario. That's where I'm at, and I want to figure out what's going on here. So I confirmed everything that they found, that it overheats very quickly, that the temperature of the coolant via the PCM, the powertrain control module, which has a temp sensor, a little thermistor in the coolant passageway in the cylinder head, was reading a real number, what you would expect, 80 some degrees. You run it for a few minutes, gets up to 100 some degrees, but doesn't really matter what that number reflects. This gauge on the instrument cluster is pegging red hot, saying it's overheating. You get the warning message. And again, I did see the P1299, which is cylinder head over temp protection active, and it's a fail-safe to hopefully protect your engine in the event of a cooling system overheat so you don't damage it any further. That's the idea. It's going to limit the electric throttle, put you into like a limp mode to hopefully protect your engine in the event of an overheating. But I did find there was another code in the PCM. Now, they may have seen this and just not known what it was. I'm not sure, but the code that I found was a U1035. And it was actually kind of difficult to find information on this code. Identifix did have some good information, but finding out what this code meant was actually kind of tough. The best description I got from it was actually in my scan tool, which said no communication with coolant level sensor. All right, and if you look in the service information for a 2013 Ford Escape, you actually don't find a whole lot of information on this coolant level sensor as it came from the factory. And the reason being is these vehicles, this particular application, did not come with a coolant level sensor from the factory. There just was none on there. And if you dig into the TSBs and the recalls, there was actually a safety recall for this model of Ford and a few others. There was some Ford Transits and Fiestas and stuff like that as well. But on this Escape, there was a safety recall to correct localized overheating of the cylinder head. And this localized overheating of the cylinder head could cause a crack and an oil leak, which could lead to a potential fire. All right, and so a safety recall is something that the dealership is going to fix for free because it generally relates to some sort of safety issue. And obviously, your vehicle starting on fire is a pretty big safety issue, so they're going to correct this. And if you go into the document in this recall on what the dealership is going to do for this recall, it's a pretty lengthy document. I'm talking 55-page PDF of technical information on what they're doing to correct this. It's not just one thing. They actually have you do a number of things with engine shielding and other things, which I'm not going to get into because you can go read the 55-page document if you want to, but odds are Ford techs are the only ones that are going to be performing this. But the two things that I want to take note of here is that a coolant level sensor is installed into these vehicles that was not there from the factory. And this is a sensor that is near the coolant reservoir on the passenger side of the vehicle, obviously under the hood, and is going to monitor the coolant level. And the other part of this recall is there's some programming that's done to the PCM and to the instrument cluster to now observe this coolant level sensor because, well, it wasn't there before. So back to the code, I have a U1035, no communications with my coolant level sensor. So could this have anything to do with the problem that we're having as far as the overheat, or at least perceived overheat condition that the instrument cluster is telling us about? And it's necessary to kind of understand what Ford's doing with this sensor. The issues are related to one another. It is because we don't have communication with this coolant level sensor because the PCM cannot talk to it, that it is going to actually go into this overheat protection mode. And they don't come out and say it in the recall and the information, but my best understanding of this is that they're doing this as kind of a cover your butt sort of scenario. Okay, they had some fires in some vehicles due to this overheating, and if the coolant level is down for any reason, that's basically going to be, okay, the potential is there for overheating, let's go into this overheat protection mode, even if the coolant temperature isn't necessarily to that point. And if the PCM can't talk to that level sensor at all, again, it's a cover your butt sort of thing, that we're just going to go into that default overheat protection mode no matter what. That's just going to, we're go into that mode whether the engine temperature reflects that or not. So that's what's happening. The PCM can't talk to this sensor. So we need to understand the sensor a little bit. Obviously, I want to check to make sure that it's on the vehicle, and I did. The sensor is present. It wasn't an engine swap deal where they missed some components. It's there. But how does this sensor communicate? Because this is a network code. This is a U code. How does this sensor communicate with the PCM to tell it what the coolant level is at? And that's where understanding what's involved with the recall is going to help us fix the car in this instance. So when this coolant level sensor is installed, it is actually installed into the CAN bus network for the vehicle, the network between control modules, one of those being the powertrain control module. And it is actually going to be inserted into that network and is going to talk on that network like a module. You could consider this sensor its own little control module, which many sensors nowadays are set up this way, where it's not just outputting a voltage like a traditional TPS or map sensor putting out 0 to 5 volts directly to the PCM. Now it is sending data packets, it's sending information onto the network, zeros and ones, to other control modules. In this case, it's going to be the powertrain control module. And if the powertrain control module does not receive those messages, it is going to set this U code, and it's also going to go into the overheat protection mode that we're experiencing for this vehicle. So my job at this point is to figure out what went wrong here. Why can't the PCM talk to this coolant level sensor? And to explain what I found, I am going to ask something of everyone who is listening. I'm going to put a picture up, number one, on the website for this episode, but I will also put it in the Facebook group. So if you're either in the Facebook group for Automotive Diagnostic Podcast, or you go to autodiagpodcast.com and find this episode, maybe you already are listening to the episode through that method, there is going to be a diagram that I drew myself of the sub harness that is also installed when they perform this recall and when they install the coolant level sensor. So when they put this coolant level sensor in the vehicle, they bolt it up over by the reservoir, and there's going to be a plug-in in it, and it needs to get onto the CAN bus. It's actually physically wired up to the CAN bus. But how do we do that on a vehicle that wasn't built for that? When it came off the assembly line, there was no intention of there being a coolant level sensor, an additional module on this CAN bus. So here's what they did. And again, what I'm asking you is to take a look at this diagram. I'm going to do my best to explain it over audio only, but if you take a look at this thing, if you look at the picture that I have drawn out, it is going to make a lot more sense. So give yourself just a moment here. Obviously not if you're driving, you can look at it later and I'll do my best to describe it, but if you're able, pause the podcast, pull up this picture, take a peek at it, and what I am saying here is going to make a little bit more sense. So when they install this sub harness, obviously one end is going to be connected to the coolant level sensor. This sub harness is then going to go over to a 20-pin connector. All right, it's a larger connector, and on the back side of that 20-pin connector, there's going to be two other connectors. So I've actually numbered these connectors in the diagram. So our 20-pin connector is 1, so that is connector 1. And coming out of the back side of connector 1, you will have two 6-pin connectors, which I have labeled 2 and 3. So 2 and 3 come out of the back side of connector 1. Now connector 1, our 20-pin connector, actually gets plugged into a jumper box, which they have you attached to the side of the battery box. And I'm not really sure what's inside of this jumper box. It's a plastic box which obviously plugs into the 20-pin connector, and I'm assuming it just shorts some terminals together. There could be more going on in there. They don't lay it out exactly what it's doing, but my guess is we're jumping some terminals together. Maybe there's some resistance values added. I'm not 100% sure here why they chose to go this way, but this jumper box was not included in the factory vehicle, just wasn't there. And so this is something that you add on with this sub harness. Now, that doesn't answer how we get onto our CAN bus. Well, off of connector 1, I mentioned there are two other, there's wires coming out of the back of this, and they go to two 6-pin connectors, one male, one female. This is connector 2 and 3 if you're looking at the diagram. So these 6-pin connectors, what they do with this is there is another 6-pin male-female connector right on the side of the battery box. It's just clipped into place there. And this connector just happens to have CAN bus wires running through it. All right, so again, male, female, 6-pin connector. This is from the factory. This is on the factory harness under the hood, but it's just a connector that has CAN bus wires going through it. And what they have you do is disconnect this connector. For anybody who wants to get specific, it's C1035C under the hood by the battery box. You unplug this connector, and then you take connector 2 and 3 from our sub harness, and you're basically putting it in the middle. All right, so to the male goes the female connector, and to the female goes the male connector. And now we have basically inserted another leg of the network, which goes to our coolant level sensor and the jumper box that's plugged into the 20-pin connector. And now that coolant level sensor is essentially on that CAN network. Now we have to program the PCM and program the instrument cluster in order for it to recognize that, hey, you're on the CAN bus now. We were looking for messages from you as far as what the coolant level is. So in a nutshell, if you weren't able to look at the diagram, we're unplugging an existing connector and we're kind of splicing in this sub harness so that our coolant level sensor can talk. That's how it's set up when they do this recall, when everything is done correctly. Okay, now on to what happened with this vehicle. I had to do a little bit of reading, and quite honestly, the information in Identifix was very helpful here to guide me to fixing this vehicle to find out what's wrong. And remember that they did an engine on this. They had everything apart, the whole front end, a lot of stuff disconnected as far as wiring harness goes, and they ended up not getting everything back to where it was supposed to be. So our connector, that C1035C, the existing connector where we split to jump into the CAN bus network, that was just plugged into itself like you would normally see from the factory. The jumper harness was nowhere to be found, or the sub harness was nowhere to be found. This thing was plugged in like the recall had never been done to the vehicle. Now, obviously, the PCM's looking for this sensor, and the sensor's on the vehicle. It's been done. So I need to figure out where is this harness, because I don't see it anywhere near the battery box. There's no extra connectors just laying around. So I thought I'd start at the coolant level sensor, which is on the other side of the engine bay near the reservoir. So I follow the harness because the sensor's plugged in. So I follow the harness, and it goes down, and it goes in front of the radiator, and actually goes down, and you kind of lose it as it goes down along the driver's side of the radiator. I'm like, where's this thing going? And we got it up in the air, and what I found out that they did was they actually routed this harness down to the front bumper. And they have our connector 1, our 20-pin connector. Again, it's helpful if you look at the diagram here so you know which one I'm referring to. They have this 20-pin connector plugged into the harness for the front bumper. So this is everything for fog lights, ambient temperature sensor. There's a number of things in the front bumper, but it uses a male 20-pin connector, and this sub harness has a female 20-pin connector, and they actually fit together. Okay, so again, this 20-pin connector from the sub harness for the coolant level sensor, it's meant to be plugged into a jumper box. And I don't know where that thing is at the moment. I don't see it, but they have this plugged into the front bumper harness, and the two connectors that come off the back, the 6-pin connectors, this would be connectors 2 and 3, they're actually plugged into each other. All right, so the two that come out of the back of connector 1, they're snapped together, and our 20-pin connector, connector 1, is plugged into the front bumper harness. Obviously not supposed to be that way. So now I have some stuff I have to ask myself, okay, well, where's the connector that does go to the front bumper, and where is the jumper box that I'm looking for, that little plastic box that jumps pins together? So I pull the harness back up, and I get the 6-pin connectors 2 and 3 in their correct position. I get them into where they're supposed to be plugged into on the battery box. I split connector 1035C. I put the other two in place. Again, I have no harness in sight for my front bumper, and I have no jumper box to plug in connector 1 to. They don't seem to be there. Well, it took a little bit of digging, and they had kind of shoved this harness up into between the PCM and the body of the vehicle. And the PCM's on the front corner of this vehicle in a plastic box. And I see this harness that is supposed to be plugged into the front bumper. I see that they plugged the jumper box into that and just sort of shoved it between the PCM and the body of the vehicle. So I unplug the jumper box, I plug the harness that's supposed to go to the front bumper in, and then I plug the jumper box into my sub harness so that everything's back where it's supposed to be. Now, if you didn't follow all that, I realize it's kind of difficult to do over a podcast. Take a look at that diagram, re-listen to this, and it'll make a little bit more sense. And I may even draw another diagram to show how they had done this incorrectly, because the diagram I'm going to post is everything connected the way it should. And I'll tell you what, I will redraw the diagram. I will show you what they did, how they had it set up incorrectly. And that might be something, maybe take a look at that and then re-listen to this and it'll make a little bit more sense. But to make a long story short, they had everything plugged in the wrong spot, and it was eliminating the possibility for the computer to talk that level sensor. Once we got everything plugged in correctly, no more overheating warning protection, no more network code. We fixed that one. Awesome. It's not overheating anymore. It never really was, I guess. So that was it for that concern. That's what they called me in for. They're going to continue on and put this thing back together and get it down the road for their customer. Well, the next day they called me back and they said, we're not overheating anymore, but the air conditioning isn't working. We're ready to send this thing out, but we can't get the AC to work. But they also noticed that on the dash, there's a temperature reading for the outside of the vehicle, and that this temperature reading is about 5 degrees Fahrenheit. And just for reference, this time of year, it's about 80 to 90 degrees outside. So obviously way off its mark. And like most vehicles, if whatever computer is in charge of running the AC compressor, in this case it's the PCM, sees that the ambient temperature is below freezing, it's not going to operate the compressor. Well, why bother? What do you need that for? Maybe to dry out the air, but 5 degrees you're not going to get AC operation, and it didn't turn on the AC. Now it didn't set a code, but it really did think that, okay, it's 5 degrees. Maybe after enough time there may have been a code set for rationality, because a lot of times computers will look at multiple temperature sensors and see, does this make sense? If every other temp sensor on the vehicle says it's 70 degrees at a cold start, but your ambient temperature says 5 degrees, there could be a rationality code. I didn't get one of those at this point, but either way, kind of know what we're after, as soon as I jump into this thing. First thing I want to know is, where is the ambient temp sensor and who does it report to? I had actually mentioned this earlier. The ambient temp sensor is located up on the front bumper. Well, come to find out, they knew that, and they also replaced this that day to try to fix this, and it didn't change the temperature that was being reported by the PCM to the dash. And I should also mention that the ambient temperature sensor reports directly to the PCM. So that's the control module that we're going to be looking at to see, what is it seeing? What is it perceiving as far as temperature? Because we know the number's wrong. And then how does that message get to the dash? And there is a CAN bus network, like I mentioned, and there's actually a couple different networks on this vehicle. That message is actually relayed to the BCM and then sent back out to the instrument cluster and the front display module, which is the screen in the center of the dash, and both of them have a temperature readout for the outside temperature. That being said, we can reference the temperature based off what we see on the dash, but we really want to focus in on the powertrain control module because he's getting that information directly from the sensor. Now, this is a normal thermistor. There's nothing really special about this sensor. It has 2 wires. There is a yellow-violet wire, which is going to be our signal wire for the sensor, and then there is a green-blue wire that does change color at some point, but that's going to be our ground to the sensor. And this is how all thermistors operate. We have a 5-volt regulated voltage, a 5-volt reference inside the PCM. It is going to be sent across a fixed resistor, which is located within the PCM, and then it is going to be sent out to the thermistor, which is just a resistor that changes resistance with temperature. So you have a fixed resistor in the PCM, you have a variable resistor in this thermistor, and as temperature changes, that resistance changes, which effectively changes the voltage drop and the voltage that we see on the signal wire, as long as the ground side is good. And what you should see on any thermistor, let's say I unplug a thermistor, I should see 5 volts on one wire because now we have an open circuit, there's no drop, and I should see a ground on the other side, and that's normal. And then if you were to plug that thermistor in, you'll still see a ground on one side, and then on the opposite side on your signal wire, you will see a varying voltage based on the resistance of the actual thermistor, somewhere in the neighborhood from 0.5 volt to 4.5 volts, and that's going to correlate to a temperature for the PCM for whatever sensor that is. That could be the transmission fluid temperature sensor, the coolant temperature sensor. In this case, it's ambient air temperature sensor. So again, pretty standard operation. This is how a thermistor works. I'll tell you, if you understand a thermistor circuit and the voltage drop, how that's working, it really does help you understand a lot of different circuits in the car. The PCMs, control modules, they're going to use that voltage drop method in order to monitor circuit integrity. Not exactly like a thermistor, but the same idea where we're using a fixed resistor in the PCM and a reference or a bias voltage in some cases to see, is this circuit open or is it shorted? If you really get that thermistor circuit operation down, you can apply it to a lot of different areas. The theory is the same. So I encourage you to look up some information on that and really understand that thermistor circuit. It's going to help you out a lot. But back to the car. I look in the PCM at the scan data and I see the same thing that's reflected on the dash. 5 degrees and it's close to 90 outside, so obviously I know that's not right. I go to the sensor, which is in the front bumper, and come to find out they actually did replace this sensor that same day in attempts to fix this. So now we need to do some measuring because replacing the sensor didn't change anything according to what they said. So what I'm going to do is, and this is a test you can do on, again, pretty much any thermistor. It is a really quick, easy check, is unplug the sensor. And what happens when you unplug that sensor, you probably set a code in a lot of cases. Not every single control module will set a code here, but if I'm looking at the scan tool, I'm looking at the data pit. I want to see what does the control module see on this circuit. I should expect to see negative 40 degrees Fahrenheit. That's kind of the low point for all of our thermistors on all vehicles, regardless of what it's measuring. Negative 40 should be present at an open circuit. And then if I jump those together, and you can do this safely on a thermistor circuit, you can take a jumper wire or paper clip or whatever, you can jump those two circuits together. You should see on the scan tool what's being reported by the PCM. That number should peg the other direction. For a coolant temp sensor, it's 240 degrees. Different sensors may have some different ranges, but you should see it go hot as opposed to 40 below zero. And that's just a real quick circuit check to make sure that the circuit's intact and the module can see what's going on. So I do that in this case, and this is what I find. When I open the circuit, when I have nothing connected at the connector, I just disconnected, it does drop to negative 40 like I'd expect. But when I jump the circuit together, when I basically create no resistance at the thermistor, I'm taking the resistor out of the picture, I'm jumping the two wires together, I should have a full 5 volt drop across the fixed resistor inside the PCM. I shouldn't have any voltage after that, and the PCM should see that, and it should reflect that as the hottest possible temperature. And I don't know what that is on this vehicle, but I'm guessing it's going to be somewhere in the neighborhood of 200 plus degrees. Well, in this case, I only get about 30 degrees out of it. All right, so I have that connector jumped, ambient temp sensor out of the picture, and I have 30 degrees read on the PCM. So now I need to decide, okay, is this the fault of the PCM? Is it not capable of reading this circuit correctly? Or do we actually have a circuit problem? Well, let's look into it a little bit more. And at this case, what I did is I actually plugged the sensor back in. And what I ended up finding was that, I'm getting my proper 5 volts to the sensor. And that was actually best checked unplugged, but I'm getting my 5 volts to the sensor, and I am getting a small voltage drop across the sensor, but here's what the problem is. I actually had 4 volts present on the ground side of the circuit. All right, so again, we get signal wire going to the thermistor, and then we have our green-blue, which is just supposed to be a ground, going back to the PCM. The PCM provides the ground for this ambient temperature sensor, and I have 4 volts present on there. So no matter what you're measuring, doesn't matter what circuit it is, if it's a thermistor, if it's a headlight, it doesn't matter. If you have voltage present on the ground at all, especially 4 volts, you got a problem. And what that means immediately to me is I have excessive resistance somewhere else in the circuit. Because if we add another resistor in series to this circuit, that means that there's going to be voltage drop across that resistance. And that means all the voltage that should have dropped across the thermistor didn't. And so we are not going to get the correct reading as far as what the temperature is. So at this point, I'm not sure if this is the fault of the PCM, but I need to figure out, okay, do I have extra resistance somewhere on the ground? So this ground circuit comes from the PCM, it goes to the junction box by the battery, and then it goes down to our front bumper where the ambient temp sensor is located. So I follow this back. I tested at the jumper box first because it was actually really easy to get to the connector that I was looking for. I was able to access the wire. Okay, I check it, I still have 4 volts there. So then my next stop is down by the PCM. And this thing was actually kind of tough to get out of its little plastic container. It had some bolts that stripped out, but we did get to it. We got to the wire. I tested at the PCM. Okay, again, this is the ground wire for the thermistor. And I have 4 volts right at back probed at the PCM. So I disconnected the PCM, I made sure the pin fitment was okay, it was all good. It actually hadn't even looked like they've been into this PCM at all, so not man-made there as far as I can tell. And then I also checked the grounds to the PCM because, of course, if the PCM doesn't have a ground, a proper ground, it can't provide ground to another circuit like this one. But all 4 of the grounds checked out, I checked out all the powers. There really wasn't anything else besides the fact that something was wrong inside that PCM. It was not able to provide this ground. But I wanted to do one more thing here. Again, I just wanted to test the PCM's ability to monitor this circuit. And so what I did was I actually jumped a ground to this circuit right at the PCM just to make sure that, okay, if I ground it here at this point, if I provide a ground at the PCM, is that ground getting to the ambient temp sensor, and can the PCM read the proper temperature? Now, this was something interesting that I wanted to note. I wanted everybody to be aware of because, heck, maybe we'll run into something similar on one of these vehicles. So once I did this, I looked at the temperature in the PCM, and it read correctly. It was 80-some degrees when I did this. Ambient temperature read correctly when I provided a ground on the green-blue wire at the PCM. And I could be wrong on that circuit color. It changed color a couple times, but it's the ground wire for the thermistor, for the ambient temp sensor. I am providing a ground that the PCM should be providing, but it's not. And once I do that, the temperature in the PCM reads correct. Great. But something else I noticed, that the temperature on the dash did not change when I did this. And this actually caused me to struggle and stumble for a bit because I couldn't figure out exactly what was going on. No matter what I did, I couldn't get that temperature to change on the dash. Key cycles, clearing codes, none of that seemed to matter. None of it seemed to change. Again, in the PCM it read correctly, but for some reason on the dash it wouldn't change. It still said 5 degrees. Well, after stumbling around for quite a bit, I ended up finding out, and this is just something maybe you want to keep in your memory banks, if you have a temperature that's wrong for whatever reason in that PCM, no amount of code clearing or leaving the key off is going to correct it, maybe after a certain amount of time. But if you want to change it, basically change the message that the PCM is putting out on the bus, because that's what it is. The information center or front display and the instrument cluster, they're getting that temperature reading from the PCM off of the network, and that PCM is broadcasting that message saying, hey, it's 5 degrees out, and it must have kept saying, hey, it's 5 degrees out, even though in the data stream it reflected the correct temperature. Here's what I did, and here's what you might need to do in this situation, is clear the keep alive memory. Okay, so they put the reset cam, and that is inside the PCM. As soon as I did that, it started broadcasting the correct message out to the rest of the vehicle. The temperature changed to the correct reading on the dash, which is, I just wanted to confirm that if I provide a ground on this circuit, is everything good? It was. AC compressor worked. Okay, PCM needs to be replaced. It's not providing a ground. So we did replace the PCM. They got a used one for it. You can actually do that on Ford, so you can program a used PCM in. We programmed it up, and everything worked. AC worked, and this thing's ready to go down the road. So my only question that I had was, why that one circuit? What happened there? And sometimes PCMs just fail. That's definitely a possibility. I've seen that happen, but I just thought it was very curious. And, you know, was it there before? I don't know. Here's the one thing I did consider, and I don't have real solid proof of this. It's just sort of speculation. But they had that jumper box. When we mentioned the first problem, which, I don't know exactly what's inside this box. I didn't take the time to do a bunch of measurements, but I think it's jumping some circuits together, maybe providing resistance. They took that jumper box and they plugged it into the harness that normally goes to the front bumper. All right. And in that harness is the wiring for the ambient temperature sensor, one of those being that ground circuit. So is it possible that we maybe jumped some terminals together using that jumper box that ruined the ground circuit for that ambient temp sensor while they had it plugged in incorrectly? I think it's definitely possible. So, is it their fault the PCMs failed? It's potentially. Again, I don't have any proof of that. That was just some speculation, and I let them know, but I'll let them handle that how they want. The car's fixed either way, so I guess it doesn't matter too much, but just something to consider, that don't plug stuff in to the wrong spot, even if it fits, which it did in this application. Strangely enough, those 20-pin connectors were the same, but you got to make sure that you're plugging things into where they belong. So that's it for today. Thank you for listening so much. Hopefully you got something out of this. Hopefully you found this interesting. I'll be getting some more case studies up on here soon. But other than that, let's get out there and start fixing the world one car at a time.